everybody. In tonight's omarvision tutorial, I am still in the world of marching cubes, and as you can see here, these other 4 videos I've had, or there's really just 3. These other 3 videos I had, I dealt with me discovering the marching cubes algorithm, and this is using halfway points. This one was actually using linear interpolation to get a smoother mesh that gets generated, and then this one I just played around with colors on the mesh generated from the marching cubes algorithm. But tonight I had a request to do a implementation, a practical use of the marching cubes algorithm, like in a game. So what I did was I kind of made this project here where you get to like drive around this little robot, and I'll show you the game here in a minute. This little usage, come on. Okay, so you drive around this little robot over this terrain that was generated as a marching cube algorithm. And the thrust ain't working. I gotta put more power. Anyway, so I could drive around this little robot, and then with the mouse, I could click on areas of the terrain and either make that area grow with the left mouse button, or make an area shrink, or dig with the right mouse button. Okay, so this was just a way to like have some type of game where I'm actually editing the terrain as I'm playing. I can even let me just dig in here, and I'll just actually make a tunnel. Let's go underground here. Make a tunnel. Come on, baby. Let's get on there. Whoa, I fell in a hole. I think I'm gonna have a problem now because I fell over. But anyway, so how did I do this? I'm not gonna start over from scratch. I'm just gonna explain to you the different parts. Okay, so first I had to have the thing that's actually the marching cube terrain, and that's this thing here called chunk01. And I have a chunk01 script that I attach to it where I have the size of my marching cube area, my 3D volume of space that I'm going to divide up into grid points, evenly spaced grid points. So the space on right now is 40 by 20 by 40. Then I assign the material that you saw that was grass, and the surface level that determines the height of the 2D Perlin noise terrain. This is the value that will decide what's inside the mesh or outside the mesh. And then the point size for the grid points. So let me just up this up a little bit, like to 0.5. And then this is the edit speed for when I click on the terrain. If it's the green ball, it's adding to the terrain so the mesh grows, and if it's the red ball, then the mesh shrinks. So here's the green ball, and it grows. Or the red ball, and I can shrink it. Okay, kind of does it wherever I click. So that's what those are on the chunk. That's controlling like the things here. Now, the ball that's actually being used to add stuff and remove stuff, it's this terrain editor object here, and it's basically a sphere, and the grid points for the marching cube 3D volume, they're set as triggers, because basically, if I were to, let me just try to show. Here, there's a bunch of cubes in 3D space right now. Let's get to it here. Yeah, you see? There's all these 3D cubes. There's a bunch of colliders in space, and that's how it's detecting when that terrain object hits one of these points. It kind of would turn the chunk to make the mesh grow or shrink. And let me just, here, just make this a little bit smaller. I'll say 10 by 10 by 10, all right? And that way there won't be that many points. So this is explained in the other videos, but the marching cubes basically works by the space is divided up into these grid points, all right? So each of these points, I have them as 3D objects that are the size of 0.5 each of them, and then they're set as triggers. So of course, even though they're there, I have them as triggers so I could move my object through them. I don't want my game object to interact with those points. I want it to be able to move through the space. So the grid points are triggers only. But since they are triggers, when I do use this terrain editor sphere to add or remove, the trigger of the terrain editor sphere can interact with the triggers of the grid points. All right. So let's see the code of the chunk, the thing that's making this terrain. This is the code for the chunk. And here's the public variables that you saw in the inspector window, the size, there's a grid point array, which I made it public. Why? Let me see. I made it public, but it's not showing over here. There's a grid point array, there's a material, the zoom level, that says how many hills, or if it's more hilly or less hilly. The surface level, that those are the values of the points. They could have values from 0 to 1, the grid points. And so the surface level, this is the point at which above 0.3 is outside the mesh and below 0.3 is inside the mesh. And there's the point size, the edit speed. All right, so then making this mesh, when you make a mesh in Unity, you need vertices, which are points in 3D space, and then you need to connect the vertices to make triangles. So I need these two arrays. So I have an array here so I could like set the data up for the mesh. And then I have UVs, which are how to draw these grass patterns on a triangle. As you can see, each one of them, each of these triangles has a pattern of grass drawn on it, and the UVs are basically the mapping of a 2D image to a triangle, okay? And then I have a grid cell because as I go through the marching cube algorithm, I want to give it 8 points at a time, which would give it a cube, basically. It analyzes that cube and then makes the faces in each cube. And this update request thing is a way that I kind of don't get overrun with redrawing the marching cube mesh there. So let's see, in the start function, I'll allocate my grid point array. Okay, so based on the size that you want the 3D volume to be for the marching cube thing, it makes an array of grid points where each point is 1 unit apart. Okay, and after I allocate that array, the P array, then I'll actually make the grid points in 3D space. So that will come here to this function. So it is a 3-dimensional array of x, y, and z. So for each x, y, and z, I will actually create a game object that's a cube, okay? And then I'll set the parent to the chunk. That's why over here you could see so many cubes, because the parent is the chunk. And I will set its position to the x, y, z that I'm at, and that's how come the cubes are all spaced out. The array does start from, let's see, if I could just position this, it'll start from 0, 0, 0 over here, and it goes outward like this. So this is the first, this is the 0, 0, 0 cube. This is the origin of the 3D volume, and then all these cubes are made going out in those directions, the position. Then the scale, this is the thing, like how big are they? They're a whole unit size of 1 or less than 1. So, I kind of made them bigger so that when I have that sphere, that will definitely hit a grid point. Then, let's see, then this game object that I just made, this cube, I want to get the trigger, I want to get the collider of the cube that was created and set it to be a trigger. Okay, so if you could see, here's a cube that's created, and Unity will give it a box collider, and then here it checks the trigger, so is trigger. And then I make sure that the cube is on a special layer called the ignore raycast layer. And I'll tell you why I do that later. But just remember here, when I make those grid points, they're on the ignore raycast layer. I'll tell you now. The reason is, like, when I am playing the game and I click with the mouse into the scene, I want the ray that I cast where I click the mouse, I don't want it to hit one of those cubes. I want it to only hit, I want it to ignore the cubes. So when I send out a raycast to see where I click on the mesh, so that that side of the mesh could grow or shrink, I don't want to intercept the cube. I want to intersect the actual triangle of a mesh. So what I could do for the raycast command, it will ignore any objects that are on layer, ignore raycast. So that's what I'm doing here. I'm making sure that this grid point cube that I'm making is on the ignore raycast layer. Okay, so that's making the point. Now I want to get a value for the point. So the points will have values from 0 to 1. And that, so it could be 0.1, 0.2, 0.1222, whatever it is. It's somewhere between 0 and 1, and I'm calling that the noise value. So each grid point gets a noise value between 0 and 1, and Perlin 2D, it's kind of giving it a smooth rolling change in values, which did what you see here in the game. It kind of makes a smooth, terrain-like change in values. They're not jiggity-jaggedy so much, okay? And that's the noise value, all right? So now I want to attach the grid point script to this game object that we created, to the cube that we created. So I add the grid point script that I wrote over here. Where is it? Right there. I add that to the game object, and then I assign it a position as a chunk. So basically, if I was going to have like an endlessly large terrain in the game, I wouldn't have this one, I'd have a bunch of chunks. And that's so that when I kind of update a chunk at a time, the game will be responsive. So I kind of divide up a large terrain into little pieces of terrain. so that when I do some editing of terrain like this, it only has to go through a smaller volume instead of like an immense volume. That will slow down the game. So I have a chunk position, which is basically the position of this chunk in world space. So that will be the chunk position. Then that noise value that we calculated with Perlin noise, I assigned that grid point of value, and I use that to define a color. I'm not visually showing my chunks, but if I were, you could see each of them as a color. You know, so they actually go from like black to red. The red ones are inside a mesh, and the black ones, the more black they are, the more outside the mesh they were. And then if the points are visible, true or false. So I think I could actually show you the color of the points here if I change this to say true in the script, okay? And then let me just start the code over again. So the points will show with the colors, and you can see what I'm talking about, where they each get a value assigned. And they didn't show. Did I save my script? No. All right, so let me save the script with the change that the points are visible, so you can see what I'm talking about with each point getting a value. And come back here, and then press play. Okay, so now you can see that the space is divvied up into points where the redder points are, the most red points are below the surface that is being separated as a mesh. And then past that value, past that certain value of, what is the value? Of surface level of 0.15, that is above the, that will be considered the other side of the mesh. So everything below the surface here, or above the surface, this is the separator, and the marching cubes just drew a line between them. All right, so like say for example, if I change the surface level and make it a larger value, like, I don't know, 0.3, let's say, and I press play, you'll see that the terrain will be a little bit higher because it's taking, whoa, it's taking values that are, see how it's a little bit higher, the terrain now? It goes up this high. Because it's taking the values to be inside the mesh or outside the mesh, it's 0.3 instead of 0.1. So you see it could take more into the inside the mesh part. So that's a surface level, that's what that's doing here. And that's showing the point. So now let me just put it back to not visible because, you know, I can't have those points showing in the game. So this goes through and it makes all those grid points. That's all that this method does. It makes the grid points, gives them their values, you know, what you're seeing. Let's see what else happens after that. It marches the cubes. It actually does the marching cube algorithm to make the mesh. So in the marching cube script that I have here in the project, that's the thing that implements the marching cube algorithm, I get the mesh. That makes sure that chunk 01 will have a mesh renderer and a mesh filter object. Okay, because you could see here, chunk 01, when the thing starts, it was just basically an empty game object, and I added the chunk script. When this game runs, it adds the mesh renderer and the mesh filter. So get mesh does that. And then over here, we have our arrays that are keeping track of the data to build the mesh. So first we're going to clear them out because we're going to run the algorithm. We want to make sure everything's cleared out first. This is just a little representation to show like the cube points. It's A, B, C, D, E, F, G, H. This is the labeling of the points, the way we could think of them. So down here, when we go through the grid, you know, we go through for every X, Y, and Z of the grid. Well, I could show the grid again. We're going to take every 8 points, okay? So for every 8 points, that's a grid cell, or basically it makes a cube with 8 corners. So I'll define the 8 corners, the A, B, C, D, the E, F, G, H. I'll give it from my array of points, okay? And then I'll just call the marching cube iso faces function. So the iso faces function takes the 8 points and the surface level, and what it's going to do is it's going to figure out, how did it do it? It's going to figure out the faces to draw for that cell. And then after it gets the data for those faces to draw for the cell, I just call create cell, which is, go to definition right here, and it'll take the vertices, it goes triangle by triangle and makes however many triangles are necessary in a cell to separate the points that are on from the points that are inside the mesh to the points that are outside the mesh. So sometimes there are no triangles drawn for some of these cubes, as you could tell, you know, over here. Sometimes if you're totally inside the mesh, there's no triangles that are drawn. The triangles are only drawn in cubes or grid cells where there's a difference, that it's outside and inside difference. So yeah, I get the points for a triangle. I tell, this is the triangle array, which says how to connect the points. Now, the connect points matters, the order that you connect them in. You want to connect the points in a clockwise order. So the clockwise order would be, if I want this side to show, then I would connect points in a clockwise order if I'm looking at it down like this, like 1, 2, and 3. And if I wanted it the other side to render, this side is like invisible because Unity is only going to render one side of the triangle, and that's determined by the clockwise order side. And then here's UV. So, UVs are basically how do you draw a 2D image onto the triangles. So you think of a 2D image, you'll have these corners like A, B, C, D. So I just made this UV coordinate array thing to say the coordinate for A, C, or D. And it just alternates between doing A, C, D, A, B, C. So it keeps alternating between either this triangle or that triangle from the image. Okay, and that's what that is. So that kind of makes the cell. So now if I go through this whole array, I'll have all the data created in my vertices, triangles, and UV arrays. These are local to my chunk script. And these are lists. But when I set a mesh in Unity, when I set the mesh filter in Unity right here, the mesh object, I need it to be in just arrays, flat. So I convert the list to an array for each of these 3 lists. And then I call my marching cube set mesh function. Okay. So cube by cube, marching cube by cube, the mesh is created. And this happens in an instant because, we're on a computer and it's fast. Now, the one other thing that this chunk array has to do, this chunk object has to do, is respond to me clicking on the mesh with that ball, right? If I click on the mesh with that ball for the mesh to grow or shrink. So I have to respond to an event. So each grid point will have an event that it will throw if it detects that, the trigger has been hit, right? So the trigger is hit, and here on the on enable, I'm listening to the grid point on point stay event. And if it gets from a grid point that the on point stay, like something's hitting that point and the value changes, I'll just call my own on point erase function to handle that. The event passes the chunk that it's in case I have more than one chunk. And, when the time is right, when I have more than one chunk, I'll check to see if it equals the chunk that this chunk O1 script is before I request an update to my marching cube. So I have an event for the erase and I have an event for the add. So what I basically do is I just set this flag update request. Then here in the update, which happens, 60 frames a second, if the update request is true, it'll march the cubes again and redraw the marching cubes mesh. And I'll, turn the flag off. So that's the chunk array. This is important in the game behavior. So I went through and explained that script. And let me just make this back into something I could use again. Let me say 30, 30, and I don't know, 15. And then press play. Because my little robot went, woo, just fell right through the ground. And he fell through the ground again. I think I either had to pick up my robot or change the surface level back to what I had at 0.15. I'll just do that. And press play. And okay, robot's on the ground. All right. So that was explaining this whole mesh, this chunk thing here. Now let me explain the grid points because that's the thing. It's kind of been explained in the other videos, but I'll just go through it really fast. So let's see. Here's the grid point script. It has some events that I created, 2 events. I created the on point stay erase event and the on point stay add event. So here's the script that I attached to the grid points, and here is what's this doing it on enable. Oh, it just tags it as a grid point. Here's the main thing. I had to add a script so that I could detect the Ontrigger Stay event. So remember, the collider for the grid point, it's set as a trigger. Okay, so that means instead of on collision, I'm going to check the on trigger. And I don't check on trigger enter because that kind of fires off one time. I check the on trigger stay. What happened? Where's my, oh, I'm not running. I check the on trigger stay so that as long as I'm holding the mouse button and as long as, this little terrain editor is colliding with the grid points, you can see the grid kind of keeps changing. I don't have to click over and over. So I'm using the stay event. Anyway, so here I check the tag. When my terrain editor is green, you can see, look right here, when it's green, I set the tag to add. When it's red, I set the tag to erase. So here, when the grid point has the on-trigger stay event happen, I just check that the object that's colliding with the grid point, if its tag is erase, then what I'm going to do is I'm going to subtract the value of the grid point. I'll make it less. And if the tag is add, then I'll increase the value of that particular grid point. Okay, then after I do that, I just fire off the event and I pass it the chunk. Okay, and the chunk is the position of this chunk. Like, where am I? Where am I? What's my position of this chunk? All right, so you know which chunk this grid point is from. And then in the chunk thing, you could check that. If the chunk matches, then do something. But right now I'm not checking that. So that's basically the purpose of the grid point thing, to handle this Ontrigger Stay event so I can interact with it in the game. I can interact with the points. So the only other thing, which is, it's been explained in the other videos, but I'll just give you a quick overlook at this again. The marching cube script. The main thing about the marching cube script here is the tables. These are very important. I actually copied these from the internet from this guy here, paulbork.net, where he actually explains the marching cube algorithm. But most importantly, I got the scripts from him. Okay, so he thinks of the cubes in the grid as A, B, C, D, E, F, G, H, but he thinks of them in numbers like 0, 1, 2, 3, 4, 5, 6, 7. He thinks of the vertices like that by numbers. And then, since it's linear interpolation, which means you see how the mesh kind of smoothly will go from one point to the other, the edges are also considered. So here you have edge A, B, C, D, or 0, 1, 2, 3. Then at the top you have 4, 5, 6, 7. And then around the middle you have 8, 9, 10, 11. So these edges are also important. And that's what's basically being covered here for the edges. There's an edge array. And then here, the triangle array. So when there's -1s, there's no triangles being generated. But when there are numbers there, every set of 3 numbers is a triangle. Okay? Describing a triangle at 3 points. So these arrays, you don't touch them. All right? They are the heart of the marching cube algorithm, because that's what's used to make the isofaces. And see here in the isofaces, where you set the points for your particular grid cell that you're looking at. Here in the isofaces, it's going to take each of the points of the cube and determine if the bit is set or not, based on the config value, the number. And then it's going to take those points and determine if there's going to be a triangle drawn on the edge side. If there's going to be somewhere along the edge, it's going to pick a point to make triangles. So it's not the middle point always. It's going to be a point somewhere along the way, like whichever corner has more value than the other, the point is chosen closer to that side. So that's what this is doing, this interpolate edge position function, to see where that edge point is, And then based on all that up there, it's just going to go through and make however many triangles are made according to the triangle table that I said we don't touch that. It makes enough triangles to, fill that cube with as many triangles as it needs. And at most, there's 5 triangles at most. The interpolate edge position, this is how it determines how close or far from one of the points of an edge the point is. All right, and the get mesh function, this is what I was saying, that this is just a helper. This isn't part of the marching cube algorithm. This is just I pass it a game object, a material, and it'll do everything to get that empty chunk object. It'll put on a mesh renderer, give it a material, put on a mesh filter if it has to. It'll put on the, then when it gets the mesh pointer, if you are in the editor, it gets the shared mesh for the mesh filter. If you are not in the editor, if you built your game already, then it gets the mesh. And I let it be that each mesh could have 4 billion vertices by setting the format to uint32 instead of 65535, which is uint16. And I just give the mesh a name. And what's this? Oh, if you wanted a collider on your mesh, which, I have it here, that you could say if you want a collider on it or not, then I'll add a mesh collider. Okay? And for the mesh collider, you have to set the shared mesh. Okay? Then on the set mesh, like after we got all our vertices, triangle array, and UV array filled, then over here, we're passing those arrays, not the list. We pass the array versions of those things here, and it will set those to the mesh. Okay, you see, so here we get the mesh filter mesh. First we have to clear the data, then we set it to our new data that's being passed in. You recalculate the bounds and the normals, and if you can get a mesh collider, if there was one set from over here, then we have to reset the mesh collider shared mesh so that it responds to the new mesh data that we set. Okay, and then here's some of the purlin functions. I also have a purlin 3D function here, which makes like random caves instead of just random hills. Okay, so that's that. Now, the other thing I could explain is the first-person controller. It's simple, but here's where we're going to get into the raycasting to say, like, see when I'm over here and I click somewhere, this is on the first-person controller script. So here in the first-person controller script, let's see, I had some helpers. Since I'm using the mouse buttons, I just had this little mouse button thing to translate primary is 0, secondary is 1, and middle button is 2. And I had some sounds just for the fun of it, so I made a little structure to hold the 3 sounds. All right, so I move around with a move speed. I have a turn speed and a thrust. Yeah, the thrust, which, let me see what was happening. I didn't actually go up in the air, but the thrust, let me set that to something higher. Maybe 3 is powerful enough. And, okay, how about 6? Come on, get off the ground. Give me enough power. All right, I'm close to 10. There we go. So the more I put, the higher I could get out of trouble. Since I'm making all these cracks and crevices here, I want it to be able to get off the ground. Thrust. All right, now I need the camera. So my first person controller script on the robot, I need the camera because I'm doing raycasting. So I need to know, I use the camera to cast a ray from actually where the camera's looking in to the scene. So I need the camera. Then there's the terrain editor object, which as you can see, I'm controlling if it's green or red, and I'm placing it wherever I click. When I'm doing raycasting, I need the raycast hit object. Okay, let's just go down the line here. In the start function, I create my sounds. I get the renderer for the terrain editor object that they passed in, and the reason for that is because I want to be able to see it's not showing, but then I can show it or hide it when I'm not pressing the button, so that's why I get the renderer. And then I have the rigid body for my little robot, so I could do the thrust. It doesn't need to be there. All right, in the update function, here's where the controls are. See, so moving and turning, looking up and down is actually, I just did this thing. If I click the middle mouse button and drag, I could change the angle to look up more or down more. And then the thrust is pressing the space bar. And here's the terrain editing. So if I press the primary mouse button, that's the left button, then I'm going to use raycasting to find out where did I click in the scene. So here's where did I click. All right, so it's kind of simple. It just says ray equals cam, the camera object, dot screen point to ray, and I give it the mouse position. So that gets me a ray that's pointing into my scene. Now with that ray, I cast it out using physics, and I see if it hits anything. If it hits anything, then the hit object is going to be populated with information, and raycast will return true. So that's why this has that. Now there's a thing here. Raycast has a couple of different overrides. So here I'm using this one where it just takes 2 pieces of info, but there is another one here which takes a layer mask. That allows me to specify to the physics raycast if I want to ignore certain layers. Now I didn't even have to use this because physics raycast automatically will ignore any layers that are on the ignore raycast layer. So what's on my ignore raycast layer? The terrain editor ball that shows up. I put that on the ignore raycast layer because when I'm clicking out in space, sometimes the ball's not showing. I don't want to click on the ball. I want to click on the mesh. So I put that on the ignore raycast layer. So when I click with the mouse, it's not going to say, oh, yeah, click the terrain editor. The other thing, so important because there's so many of them all over the scene. I had to put each cube on the ignore raycast layer. Look at all these cubes that are here. If I had the cubes on and I'm clicking, I'm just going to keep clicking cubes. I'm never going to be able to click the terrain. So I had to put the cubes on the ignore raycast layer. See, so each cube's on the ignore raycast layer. So that way, when I click into the scene, it goes through and the thing it touches is the mesh, all right? Now, when I get that point, you know, depending on the point I click, now I'm going to add to the marching cube or I'm going to erase from the marching cube. And that's kind of like right here. This code isn't necessary anymore. I'm using the ignore raycast layer. But, you know, I play a sound. I change the terrain editor tag to add so that in the grid point script, it knows whether I'm adding to the value or subtracting from it. I also put the terrain editor ball right where I clicked so that this is what this does. And then I show the ball and change the color. So this is the erase one. No, this is the add one, so I set the tag to add. And this is the erase one where I set the tag to erase. Now, I don't need those anymore. But it's basically saying if I'm not hitting the marching cube, the object tag marching cube, which the chunk, you see I have it as a tag marching cube. So if I click on my robot, I'm not going to do anything. It has to be that I'm clicking on there. Okay, and then if I'm not clicking anything, then I just hide the terrain editor and turn off the sounds. So, you know, this is an implementation of me using the marching cubes. Okay, and I'll have this whole project on omarvision.com/tutorials. All right, I'll be right over here somewhere as one of the first ones. The orange things and the blue things. There you go. Have fun. You made it to the end of the video. I'm so proud of you. This is my website. The main thing I want to show you is that for any of these videos that you've seen on YouTube, I have the tutorial section, which has the blue links for the projects, and the orange links are the files. Also, you could go over here and play some of the games we made in the game camp.